There we go. Ladies and gentlemen, dear participants, welcome to our section on organic amendments. We will start out with a poster session, which will be a rather small one because there will be only 3 posters presented today, maybe 4, we will see. And then we have an oral session after the break with 5 presentations. Now, these organic amendments in the session, they are relatively diverse. We talk about mulch, we talk about biochar, we talk about compost, farmyard manure, even ash of organic materials are being used. And depending on the study, these organic or residues are being assessed regarding growth or yield effects, regarding soil attributes, regarding product quality attributes, and in one case also regarding the suppression of weeds. So we are looking at a wide and relatively diverse basket of different organic amendments, and we are looking at rather diverse effects that those organic amendments can have. And maybe just to tell you who is talking to you, my name is Matthias Becker. I'm professor for plant nutrition at the University of Bonn, and I have the privilege of sharing the session today. So since the session is small and we have quite a bit of time, actually, I would allow you, the poster presenters, to use 5 minutes instead of 3. And if there are additional questions in the Q&A, we will take them. We will not use the full time, but we are not under real time pressure. At this point, I would like to introduce Ghulam Haider. He is from Pakistan, working at the Hochschule Geisenheim in Germany, and he will present his work, which is dealing with enriched biochar, looking at vegetable species on a sandy soil. Ghulam, if you're on, we see your face already.
Yes.
You are now please sharing your screen, and we look forward to your presentation. If you take more than 3, if you take 5 minutes, I will not stop you because we have time. So tell us your story. We look forward to it. Thank you so much.
Okay, thank you very much, Matthias. Yes, that's sharing my screen and then. Yes, I think you can see my screen. It's visible now? Yes, ladies and gentlemen. Welcome to the poster, The Effects of Nutrient-Enriched Biochar Placed in Root Zone Varied with 2 Vegetable Species in Sandy Soil. My name is Ghulam Haider. I hold PhD from Justice Liebig University, Gießen, but right now I am working as assistant professor at National University of Sciences and Technology, Islamabad, Pakistan. And in my today's research, which is based on actually my previous research, which I have shared here, that there are 4 publications which are directly linked with this research, in which we have actually found that when we are applying freshly produced biochar into the soil, then it is causing nitrogen uptake limitation in different crops. For instance, with the cereals, with the winter wheat, summer barley, or the maize. We observed that this nitrogen, mineral nitrogen, was not plant available in the field site. And after 2 to 3 years of field aging, we have taken these biochar particles out, and then we have extracted it with different extraction methods. For instance, with standard 2 molar KCl extraction method, the nitrogen, mineral nitrogen, specifically the nitrates, they were not completely extractable with these methods. We have applied some other methodological techniques, and then we found that nitrate and ammonium is there, but it is not plant available. So based on these previous studies and recently we found that when we have applied these field aged biochar particles having this much of nitrate and ammonium in them, but that was not plant available under the field condition. We put that biochar particle as a source of nitrogen in a controlled experiment, and we were able to find that the captured nitrogen was equally plant available to the quinoa and ryegrass in another study. And on the basis of these studies, then we set two goals for the current study, that if the different fertilizers loaded on biochar can improve the vegetable crop plants compared to the same fertilizer applied pure, or does the way of placement also matters? For instance, that if homogeneous mixing in the soil, or if we are placing that biochar loaded with nitrogen in some root placement, root zone placement. In this study, we have taken two test crops, for instance, the red radish and the celery. And two factors were selected. First one was the nitrogen sources. Nitrogen sources were taken from cow urine as a one, and then synthetic nitrogen fertilizer. In the second factor, we have different methods. Pure nitrogen thoroughly mixed into the soil, either it was from urine or from the mineral nitrogen. Second one, nitrogen loaded on biochar and it was thoroughly mixed in the soil, or nitrogen loaded onto the biochar placed as in the root zone fertilizer. So in the results, if you see here, that is the dry matter production of red radish and celery on the extreme left side, you see that there is no significant effect of these treatments on the red radish. So it is the differential response from different crops. While on the right side, if you see the celery dry matter production, it has been significantly increased by the application of either urine nitrogen or from the synthetic mineral nitrogen. But when we have applied it as a loaded onto the biochar and it was thoroughly mixed, or it was as a uh, root zone fertilizer. So there is, on the basis of these results, and we already know that when cow urine or other ruminants, when they are making their excretion on the surface at the specific urination place, it is almost more than or even equal to 2,000 kilogram of nitrogen on that particular spot. So it may become a hotspot of nitrous oxide emission, which is a potent gas. So by utilizing the best quality of biochar, which has been widely known as negative emission technology, and it has the ability to suck that particular nitrogen and it can deliver to the plants according to my previous studies, and in this you have seen. So I would conclude or sum up my today's talk that cow urine can be potentially utilized as a nitrogen source when we applied it as a loading on the biochar, either thoroughly mixed into the soil, or when we are applying it as a root zone fertilizer in different vegetable crops like celery having 200 kilogram of nitrogen per hectare. So thank you very much for your attention, and I'm waiting for your questions.
Gulam, thank you very much also for staying in time. The floor is open for questions that you may have. And since I'm not able to access my Q&A right now because my handy just died, let me start out the first question. If somebody can see the questions, please let me know how to help getting there. Haida, Gulam, the biochar you used, what was it made from initially, and at what rate did you apply the biochar?
In this case, in this study, it was from we have taken apple prunings. It was This experiment was done in Geisenheim University, and right now I have an ongoing project between Germany and Pakistan, and I was there. I conducted that. It was from pruning of the apple trees, and it was at the rate of 1.5 tons per hectare.
Okay, so a realistic amount.
Yes, yes.
Good. Did you actually measure the nitrous oxide emissions?
Yes, we have measured, and I have not included that part. That is going to be a complete paper, and that was the differential response. Like for instance, when we have just started at very next third days after the application start of this experiment, from third day, the emission was flushed. It was high, but with the passage of time, it was declining, and in the end, there was no nitrous oxide emission.
There was
This
none at all.
Yeah, it is very no significant difference. We are going to publish that part.
Okay. And okay, nitrous oxide emissions are originating from nitrate formation or nitrate respiration. Did you measure also ammonia volatilization? I mean, cow urine is a potential source. We have just heard this in a previous session of ammonia volatilization from organic wastes. Is this something that you would consider measuring, or is this not relevant?
This is relevant, but in that experiment, we could not do so because there were only possibility of having three: carbon dioxide, methane, and nitrous oxide. And but I have checked the volatile this nitrate leaching. This pot was specifically designed as a lysimeter pot, and we have taken some leachates after huge to mimic the heavy rainfall, and we have taken some nitrates. But that results are not with me right now.
Thank you so much. Does any of our colleagues here in the room have questions while I'm trying to see in Q&A if there are any questions? Agenda attendees. Oh, good. My technical assistant, Q&A. No. Beep. I'm looking at my technical assistant from ATSAF TT 2020. I do not see any questions in the Q&A, but that doesn't mean that there are none. Maybe I'm looking at the wrong spot. Would you be able to assist there?
I can't say. I can see only 4 slots.
Same here. Yeah.
Yes, yeah.
Same here, and also in the chat there is nothing. Okay, Gulam, thank you so much, and there will be opportunities to view the poster. It's online anyway, and for further questions that you may have regarding this very interesting study, particularly once the trace gas emission studies are also out,
Yes.
you may contact Haider Gulam anytime at the links that are provided here. Thank you so much. And we are moving to the next presentation. Here, the second one, I'm not sure how it is going to work. Sagara, are you the second one? Pushpa Kumara?
I should stop sharing now?
You stop sharing now. And I will ask Sagara, Pushpa Kumara to switch off the mic, switch on the mic. Good. Sagara, can you hear me? We cannot hear you, by the way.
Hello.
There is a problem with your sound system. We cannot hear you at all. I'm really wondering what's happening there.
Hello.
Sarah, can you say something or share your screen or move something so that we can see you? Doesn't seem to be the case here. In that case, if you allow me, we would, while we are sorting out the technical issue with Sagara on his paper on the impact of co-compost pellets, we will switch to Laura. Laura, are you on?
Yes, I'm here.
Okay, so Laura Kuonen is from the Bern University of Applied Sciences, and her paper is co-authored by Lindsay Norgrove, and she's looking at mulching, or does mulching increase maize yields in the tropics? So it's a review paper, and she has, now Sagara has shared his screen. Sagara, please undo the screen sharing, because we are first starting with Laura, because we have a technical issue by getting your sound system going. So just please stop for the moment to share your screen, and we'll rather have Laura do that to start.
So I've sent a 3-minute presentation to the Tropentag team, and actually we could let it run, and afterwards I might answer all the questions and give some more explanations, if that would be fine.
That means you have uploaded a full presentation that we can play.
Yeah.
So here we have the poster. And I don't know, is anybody hearing
My
anything?
poster presentation. My name is Laura Konen, and I recently finished my master's degree at the University of Applied Sciences in Bern, Switzerland. Mulching is and has been frequently tested in field trials in the tropics, and each trial included different factors to evaluate the effect of mulch on the maize yield. Yet there is no systematization of these factors, and the goal of this systematic review was to answer the following question: which factors influence the effect of the mulch on the maize grain yield? I extracted the grain yield ratio and the influencing factors from 54 papers and conducted a multiple regression. Many factors showed collinearity and were removed from the model. The grain yield ratio was calculated by dividing the yield of the mulch treatment by the yield of the non-mulch control treatment. The ratio was on average higher than 1. This means that the mulch had a positive impact on the yield compared to no mulch. Mulch therefore increases maize grain yields in the tropics. What needs to be noted here is that the ratio has a wide range from 0.1 up to 7.3. In some trials, the grain yield of the mulch treatment was 7 times higher compared to the control treatment, and in others, the grain yield of the mulch treatment was lower than the control treatment. The model showed that the mineral fertilizer addition, the rainfall amount, the maize density, and the nitrogen content of the mulch significantly influenced the grain ratio. As an example, let's assume we are in a location with 1,500 millimeters of rain. Maize is sown at a density of 50,000 plants per hectare, and the mulch has a nitrogen content of 2.5%. If the maize is grown with mulch, the yield ratio is 2.3. But if mineral fertilizer is added to the mulch, then the ratio is even higher. To answer the question in the title of my poster, yes, mulch application does increase maize grain yields in the tropics. This increase is amplified with the simultaneous application of mineral fertilizer, which suggests a synergetic effect of mulch and mineral fertilizer. I also found that with higher maize densities, the effect of the mulch on the maize grain yield was lower. This might be due to the fact that at lower maize densities, the mulch contributes to suppressing weeds. But at higher maize densities, this effect might not be needed, since the maize plants themselves might suppress weeds. As a final recommendation, I would say that mulching should be combined with mineral fertilizer, if of course available and affordable, in intensified maize production systems in the tropics. Thank you for your attention, and I'm looking forward to your questions.
Thank you, Laura. So, mulching, are there questions out there to Laura regarding her review on the mulching? While you think about them, let me ask the first ones. Mulch, there are different ways. You can do surface mulching, leave it on the surface, or you can shallowly incorporate it. What was done here?
I only considered organic mulch which was applied on the surface and which was not incorporated.
And did you encounter in any of your studies problems? I mean, I know from studies in West Africa that surface mulching can multiply termites to a way that they damage the maize. So surface mulching in some regions, particularly in the forest savanna transition zone of West Africa, is a very critical issue actually, and farmers are refraining from doing that. Any experiences based on your reviews?
No, I did not really consider the effects of mulch on pests because there was very few information on this actually. So I basically only looked at the maize yield. We initially wanted to look at the influence on soil, different soil parameters, but we did not find enough papers to conduct a review actually. So we focused on the parameter which was most often considered or tested, which was the maize yield.
Sure, okay. But still, the mulch is very different qualities depending on where you're going. And you have been looking here at the nitrogen content of the mulch, but there are other attributes. There are studies that show that the lignin to nitrogen ratio or polyphenol amounts and stuff like that play a key role in mulch quality. Can you differentiate based on your study how mulch qualities differentially affect the yields of maize?
Well, the CN ratio was also a parameter which was mentioned in quite some of the papers, but then we could not include it in the analysis because in the end we didn't have enough data points on this. So we basically only looked at the nitrogen level. But of course, it would be much better to consider the CN ratio, which is a better indicator of quality of mulch than only the nitrogen level.
But how many data points did you have? It looked like a lot.
So overall for the maize yield, I had 100. So I had like answers which were 148. But then I had different factors, and not for each of the maize yields I had all the factors. So in the end, I had a statistical model with, I think it was six or seven factors, but not all of these factors were actually available for each of the maize yield answers which I found. So in the end, the number of data points included in this this model was around, let me just have a look at that. Oh, 76.
Okay. Thank you so much. Are there any questions out there? I don't see anything in the Q&A for the time being. My colleagues here in the room, Haida, Sagara, do you have any questions?
Yes, please, Matthias. Can I ask one question?
Please go.
Yeah, Laura, thank you very much for such a nice work, and you have really covered a lot of work here in this study. You mentioned that there were two main factors like rainfall and nitrogen, which were very important in the relation to the yield increase in the maize. And if some studies have also included soil temperature, because by the application of these organic mulches, there is also effect on the soil temperature, and there is a quite relationship with this microbial activity and nutrient transformation and availability.
Yes, some of the papers which I reviewed did include soil parameters. For example, soil temperature. It was actually one of the most frequently measured parameter. But in the end, like I said before, we didn't have enough data points for this parameter, so we couldn't include it in the analysis.
Okay. Thank you very much.
Thank you.
Laura, thank you so much. The poster is uploaded anyway. You can all look at it in more details. And I would now like to check with Sagara Pushpakumara. Can you say something to see if we can hear you?
Hello.
We see you already. That's helpful. Now we can hear you also. Great. We will continue our poster sharing. I don't know. Do you have a poster share screen, or is it a registered presentation? Anyway, Sagara is from Sri Lanka, if I got this right.
Yeah.
And you are working at the Ruhr University in Bochum to do your PhD, is that correct? And he will present work on the impact of co-compost pellets on performance attributes of sweet potato and Eleusine. And I think without much further delay, floor is yours.
Hello everyone, I am Sagar Pushpakumara from Viable University of Sri
Please
Lanka.
share your screen.
Co-composting of fecal sludge and the organic fraction of municipal solid waste is considered as an appropriate low-cost. Hello everyone, I am Sagar Pushpakumara from Viable University of Sri Lanka. Co-composting of fecal sludge and the organic fraction of municipal solid waste is considered as an appropriate low-cost technology that is capable of enhancing sanitation and waste management in low-income countries. As an option of further value addition, pelletization of pre-mixed co-compost is considered to reduce the bulk density and simplify field application. Biochar is used an additive and it has long been used as a soil amendment. It can provide many benefits which contribute to soil fertility with long-lasting effects such as increased soil pH and water holding capacity. Therefore, we have conducted 3 researches to investigate the impact of co-compost pellets and powder on the growth and yield of Ipomia batatas and Eleusin coracana, and to determine the optimum application rate and depth of co-compost powder and pellets. In the first trial, we focused on utilization of EFB as biochar together with co-compost in pellet form to amend sandy loam soil and evaluate its performance on plant growth and yield of Ipomia batatas. The field trial was conducted at the Centre of Excellence for Organic Agriculture, Northwestern Province in Sri Lanka. The experimental design was randomized comparative block design with 4 blocks and 7 treatments as shown in Table 1. Parameters of plant growth, yield and soil pH were recorded. The results revealed a significantly higher yield with MSW DFS pellets with 30% available nitrogen and MSW DFS biochar pellets with 30% available nitrogen treatments against the mineral fertilizer. It could be concluded that harvest of 15 to 19.5 tons per hectare could be achieved by amending soil with 16.8 tons per hectare of MSW DFS biochar pellets with 30% available nitrogen. In the second trial, co-compost powder and pellets were applied at 4 different soil depths. As a surface application, 10 cm shallow application, bottom layer application, and complete soil mixture over organic fertilizer. According to the results, the depth of application didn't have any effect on growth and yield of millet. However, application of DFS MSW co-compost recorded significantly higher growth and yield performance compared to inorganic fertilizer. A significantly higher yield could be obtained in the DFS MSW co-compost powdered form than pellet form. The third trial was conducted to investigate the response of growth and yield of Eleusin coracana to different dosages under greenhouse conditions. Plots were laid according to Latinsky design. 8 different dosages of co-compost pellets based on available nitrogen were applied and as treatment with mineral fertilizer recommended for finger millet by the Department of Agriculture, Sri Lanka as the control. A significantly higher yield was recorded in the treatment with 150% nitrogen and it recorded 65% total average yield increment compared to the control. Dosage increments of DFS MSW co-compost pellet incorporated to the soil doesn't increase the vegetative growth, yet the yield performance are increased. This result concluded that yield can be increased with extra application of co-compost pellets with nitrogen percentage, high nitrogen percentage than DO recommendation further. 10 cm depth fertilizer can be recommended for the finger millet considering the convenience of and cost of application. With that, I wind up my presentation. Thank you for your kind attention and now my presentation is open for discussion.
Sagara, thank you very much. Again, I do not see any questions in the chat, so let me kick it off. Pelleting compost is an additional cost factor. Is it worth it? Why do you go for pelleting? Why not apply the compost as compost? What is the reasoning behind the idea of producing?
Yes, when we are considering about the co-compost powder, when applying lot of powder may be lost during the rainy season and wind lost, maybe some difficulties to apply the powder form. Then that research we consider about the co-compost pellet. Actually, initial cost maybe need to install the machine and other electricity and other basic requirement. But that electricity requirement is a little more high. But when considering about the positive effect, especially the transport cost may be reduced during the bulk density may be reduced in co-compost pellet rather than the co-compost powder. Then I think co-compost pellet may be to the advantages more than powder form.
Yeah, I can believe for application and everything, it's more easy to handle. It's just a matter of price. I mean, do you think that in other environments, maybe beyond Sri Lanka, the pelleting machines will be available?
Yeah, we conduct this research with the 4 municipal council co-compost site. Then we established a new machine, and the large scale we need to build a machine and do the research again.
Okay. And you used municipal solid waste. Is there any risk attached to this material? I mean, I know in Europe you would expect heavy metals and God knows what else in the municipal waste. How is the situation in your specific case?
Yeah, actually, same as the other country. Initially, we separate the organic material from the municipal council because the municipal waste is heterogeneous collection of waste. Then initially we separate the organic particles from the municipal waste, and then during the co-composting period, actually temperature built more than 65 degrees to 70 degrees. At that time, most of the pathogens and harmful organisms may be killed, and finally we test the co-compost heavy metal and other harmful elements, but that did not recorded at the harmful level.
And an application rate of 15 to 20 tons per hectare, which sounds substantial. Do you think that's realistic for a small-scale farmer to obtain 20 to 50 or 15 to 20 tons?
Yeah, it is somehow a question when that we are doing some research by adding some mineral fertilizer to the co-compost by increase the nitrogen level in the co-compost pellet. Then we can reduce the application amount by adding some chemical fertilizer.
Okay. Are there any questions for my colleagues here in the room? Because in the Q&A, I don't see any questions right now.
Yes, I might have one question about the cost of producing the pellets versus the cost of the mineral fertilizer. Did you also look at this point?
Sorry, I get your point.
It's about the cost, the economics of pelleting.
Yeah, this we done for the research level, but when we go for the commercial level, we should consider several cost factor. Then only we consider about the research level, how co-compost pellet impact for the growth, and can municipal solid waste used to produce the co-compost pellet.
I have a question here for you, Sagara. There are differential demands for nitrogen and potassium. Millet requires more N, sweet potato requires more potassium. You selected 2 contrasting species. Are both satisfied with your co-compost pellets? The higher K needs of the sweet potato, the higher nitrogen needs of the millet?
Yeah, but in the sweet potato trial, we obtained higher yield than the Department of Agriculture recommendation fertilizer yield. But in this finger millet trial, we got less yield because that we done that experiment in the greenhouse condition. But in considering about the sweet potato trial, that is successful.
Okay. I don't see any further questions, neither in the Q&A.
Okay, hello.
No here in the room.
Yes, Professor Matthias,
Yes,
I want to ask.
okay.
Yeah.
Gulam.
Sorry. Yeah, sorry. Actually, 2-3 questions were on my side I wanted to ask, but been asked by the Professor Matthias and Laura. One additional thing I want to, this is a comment, rather a question. that when we are working
Okay.
with these composts or pellets or biochar, the main thing I have observed in my country or while I was working in Germany, this is the supply chain management of these materials. So we must have to look on these things, that how we will provide this for actual agriculture. So whenever we are working these things, we must have to look this, if we are applying these huge amounts which are not being able to supply all over the world or some particular area, then this is difficult
Yeah.
to achieve these benefits. Yeah.
Mm.
Yeah. Okay.
I think this is a very, we take this as a comment. It's a very general feature that most people in the biochar community apply relatively large, often irrealistically large amounts. That's why I liked in the first presentation when Ghulam applied 1.5 tons per hectare. This is an amount that probably a small scale farmer can carry on his back to the field. With 20 tons, it's getting already buying heavy machinery, I suppose.
Yeah.
Anyway, I think our time is up, and I would like you, first of all, I extend my big thanks to all of you who have presented, for your nice posters, for your the questions and answers were a bit on the weak side. It was rather internal discussion. There will be further presentations on the topic of organic amendments. We start at 10:30 in the session Organic Amendments, and you will hear more, and I think you will see Laura again, because she will look at her horticultural systems in Bolivia in a different study. So I hope to see many of you at 10:30. Thanks for all of you of joining us here. Thanks for the group who has joined us on Facebook, and have an enjoyable coffee break. Goodbye.
Goodbye. Take care.